Thank you so much. Cara Delia, and I am part of Red Hat. Sorry, water is important, but not right there. Shorty. I manage our AI upstream strategy, and I'm excited to be here with this very illustrious panel. I will let them introduce themselves, but I will give a preamble that this is on behalf of LFAI and Data, so think of it as not as advice or thoughts from IBM, Red Hat, SAS, or Neo4j. This is about working in a community together. So we will kick it off, and that is that open models, from our perspective, really help choice and control for enterprises, and it's going to make sure that we are not developing a monopoly around models. Where we're reliant on just a few model makers. We're going to help have your open models perspective is that we are using this for choice and control, so that we can have faster time to innovation. So with that, I will, if every panelist could just give a quick intro as to yourself, and then I will open up for the first question.
Hello, everyone. So I'm Arnaud Le Hors. I'm part of the Open Technology Group at IBM. I'm an open source, open standards specialist, and I'm the co-chair of Generative AI Commons, which is one of the initiatives of LFAI and Data, which I will talk about more later on.
My name is Adam Miller. I'm part of Red Hat Engineering Organization. I work on various things. Right now, I'm currently an upstream maintainer of OpenShell for agentic security and governance and safety. I'm currently serving as the Linux Foundation AI and Data TAC chair. I don't know, been in open source for forever, since I was in high school.
And he has the tattoos to prove it.
Yeah, I'm a big open source nerd. I've got Shadowman and Ansible and yeah. Anyways,
no, you keep it. I got one. They gave me my own mic. Yeah, because I've been in open source longer than you have. So
you're also older than me.
Well, that's true too. All right, so I'm Brett Smith. I'm from SAS in Cary, North Carolina. We're a big analytics company. We've been doing AI and machine learning longer than the current landscape thinks it existed. Currently, I am a platform engineer. I build pipelines and all this other stuff. Currently, I'm heading up the AI, the move to push AI into our pipelines. And I am super excited about open source models because I don't want to pay the Anthropic tax anymore. The rich people don't need to get richer.
I have a mic. I think I have a mic. Am I on?
You're on.
Okay, so I introduced myself before, so I'm Steven, work at Neo4j. Apologies if any of my answers include graph, because that's 90% of what I do. But it also applies a lot to model openness, because if you want to run open models, if you want to make more efficient pipelines, you typically want to do it with more expert models, kind of like Dockling, which we just talked about, or smaller models which are more specialized, and certain techniques like the one I talked about in my presentation earlier this week about like GraphRag are particularly well suited for using smaller models and open source models, because they require less reasoning leaps by the AI if you feed in the right context and you're able to supply it all the information it needs to give a good reply.
Good deal. I'll start with, this is going to be very interactive, so feel free, and casual, if you can't tell. But wanted to start off with that the core idea of AI models have multiple dimensions of openness. So the question is to the panel, what parts of the system are actually available and reusable?
So as part of my work with Generative AI Commons, I actually led the development of what we call the Model Openness Framework, which you may have heard of a few references already about. And essentially, the question that Cara is asking is a complex question, because, we talk about open source models a lot, but nobody has really defined what that means. And of course, it's easy to make a leap from, well, we all know what open source software is. Well, mind you, when we started with open source, we didn't really know what it was either, and there was a lot of chaos. Every vendors, and IBM was part of it, created their own license with different terms and license and conditions and so on. And there was actually a decision at some point to say, okay, we need to clear the land field there, and there's OSI, the open source initiative, was created to define what open source meant. And they went to, list licenses. They defined the principles of open source and then went on to list licenses that qualified as open source licenses. And essentially, this meant that to be an open source software, you have to have one of those licenses that respect the principles of open source. They are identified. We are now at a new phase where in the AI space, a lot of people are putting their models on Hugging Face, and they think, well, if it's on Hugging Face, I can download it for free. I can do whatever I want with it, right? So it's open source. And mind you, a lot of model producers are happy to make you believe it is indeed open source, when in practice, a model is actually much more complex than a piece of software, like a piece of open source software. And so this leads to this question of, in fact, there is two different dimensions. There is what exactly is included in the model distribution and under which license. So it turns out that the model openness framework defines a framework to make this kind of assessment. What is included and under which license? It's actually quite complex. And in practice, if you look at most of the models that are referred to as open source models on Hugging Face do not qualify as open source because for the most part, they don't even have an open source license attached to them. And then you can discuss whether, they actually provide enough for you to be able to do the kind of operations that the principle of open source is supposed to grant you. And so the model openness framework actually took a pragmatic approach to this problem by saying it's not a black and white question, unlike open source software, because there is all these different components that can be included. We have defined 3 different classes of openness. There's an open model, which is the basic. It addresses the most common use cases, which is you can download it, do whatever you want with it, and fine-tune it if you want. And then there is an open tooling model, which provides you a little bit more information so you can do more evaluation, benchmarking, and so on. And then there's the open science model, which provides you everything you want to possibly reproduce the model. And so we try to define those different categories, and you could argue what it goes in it and not. But we've been trying to promote this idea, and every time I talk about it, it's very well received. People feel like, okay, that makes sense. Unfortunately, I must say, we're still in an era where there is no general agreement. And in fact, there's been several efforts in that space. OSI actually tried to define what they call is open source AI definition. Mind you, they started with the MOF, but they said, no, it has to be a binary question. It can only be open or not. And so they basically had a contest as to what should be included, and they said, this is it. If you have those things, it's open. If not, you lose, which I don't think is very pragmatic. But they're not the only ones. There is like the University of Stanford as what they call a transparency index, where they sort models based on some criteria that they have selected. More recently, I saw that in Europe, they came up with the European Open Source AI Index. And it's like, so unfortunately, the jury is still out there. But I think it's important for people to understand that it's quite a complex question. So sorry for the long answer. But.
Well, so one of the things I struggle with this one too, and I think why we're having so much trouble classifying it is, with software, if you have the same version of the compiler and the same version of the code, our outputs are functionally the same. That is not necessarily true if you and I both have the same inputs into building a model. Let's pretend we both have giant piles of hardware and infinite budget, but it doesn't necessarily mean that the inputs produce the same outputs, because that's just not how these things work. So it's very different, and there's something about the composition of the inputs producing different outputs that I think kind of changes the classification of all this. And yeah, to Arnaud's point, jury's still out.
I don't have a lot to add. It's pretty much been covered. So, did you have anything, Steve? I mean, they covered it pretty well.
So, I think if you want to learn more about this, come to the Gen AI Commons group, and then you can discuss the model openness framework and a bunch of the ongoing work which is going on in this. And it is an emerging field to define exactly what open source is as it relates to models. And it's great that we have experts like Arnaud in the LFIA who are putting a lot of time and effort to try to clear this up and make it more obvious to end users of models how open the model is actually that you're applying to your enterprise workloads.
And speaking of enterprise, I'm going to move on to the next question, and that would be, what is the panel seeing around the biggest blockers? Is it around performance, governance, skills, support, or trust?
So I got the mandate to put AI into the pipeline last year. One of those top-down, you must use AI type of things. And so I've been struggling for the past year to figure out a good place to use the AI. And so that's actually like the first barrier that I ran into is like, do I really need AI? I've got this deterministic pipeline that's been running for several years. It's bulletproof. Why do I want to introduce a non-deterministic gremlin in there that, or throw grenades at it? And so it took me a while to figure out where I could effectively use AI in the pipeline to free up humans to go do other work. And so we have a process for third-party onboarding that basically requires 5 JIRA issues. And we're behind, we haven't registered about 8,000 third-party open source libraries yet. And so if you do the math, I can't do that math, it's 60-something thousand JIRA issues. And I've got 2 lawyers to do the export restrictions. They were feeling overwhelmed, and so the project I decided to do the first thing I decided to do is, export restrictions is a lawyer going through the repository and deciding whether it is classifying what it is and whether we can export it to other countries or not, and whether we have to go get a license to export it or all this other stuff. And this is a really good place to bring in local models. And the reason why I bring in local models is because using Claude to do this is like taking a Mack truck to go get your mail, right? And it got a driveway, it's 100 yards, and let's fire the Mack truck up and drive down to get the mail. Ridiculous, right? And on top of that, it's the cost. So I've been working with IBM Granite models. Thank you, IBM. They're really cool. I've been using the IBM Granite models with local inference to do the work that I need it to do to evaluate the repositories on whether they're, this particular piece. The other thing we have to do is security reviews. So we gather a bunch of information, we feed it into the system, and then we do a bunch of deterministic work to figure out where we are, and then we take that structured data and we pass it over to a Granite model, and the Granite model comes back and gives me a confidence score on what it's at. So where does that get us? So those models are free as in, are they free as in speech completely? The Granite models, yeah. The Granite models are not free as beer; they're free as in speech, meaning that I can use them and do what I need. Now, the reason why we love open source, right, is because back in the day, Windows wasn't my favorite thing, and Red Hat was great, and Slackware was great, and all these Linuxes that I've worked on all the years, and I see coming for us another revolution of open source, right? So we're staring down the barrel of AI, and it looks like 1999 again, where we have these giant corporate, entities like Sun and Microsoft, like ruling the OS world. Well, right now we have these giant corporate entities that are ruling our AI world, and the answer is open source models for the future. And if we all put our effort towards them, these models will catch up fast. Right, and we were talking earlier about Gemma 4 being close to Sonnet 4.5. Well, I wrote that whole system that I was just talking about with Sonnet 4.5. So if I can write it with Gamma 4 locally on a local inference, well, guess what I didn't have to do? I didn't have to spend my bonus writing the software that's going to help the lawyers out. And I really like my bonus. I don't know about you, Stephen, but I like mine, and I don't like spending it on other companies. Again, back to the open source thing. Now, we can contribute upstream. I'm kind of an end user right now. I don't have a lot of contributions upstream. But you take the Dockling project we just saw, which, thank you, it was wonderful. Can't wait to get back to Raleigh, North Carolina, and start whacking on Dockling. And you can take the base Granite model, right? And you can create a fine-tuning data set, and now you can fine-tune your model to be even better at export restrictions. And so that it stops telling you that there's an underwater vehicle in your ballistics library. These are the type of things I've been running into with hallucinations. And but the Granite 4.1 dropped right before we got here, and I got 1 day to test it, and I got better results out of an 8 billion parameter model than I was getting out of a 32 billion parameter model. That tells me that by this summer, we're going to be caught up in the open source model world to where we are now with these Claude models that, given the day and the amount of infrastructure and the time of day, it may or may not be smart. And so you remove that load where you're beholden to the inference that they're hosting out there. And when AWS East goes down, AWS East never goes down. Anyway, when AWS East goes down and they route you through, Iceland to go get to your inference, and your model performance is bad, and you get more hallucinations that you're paying for. I mean, at least I have a sunk cost in the hardware on the inference that I'm running. That if I have some hallucinations, not a big deal. Now, the other thing about open source models that you can run on inference is the other day, before I was testing Granite 4.1, I was in a demo with one of my colleagues because we were, going over this subsystem I'm building. And while we were talking, it got caught in an infinite loop. And it kept looping and looping and looping. And it was supposed to stop at 40 turns, but somebody wrote some really bad code. I don't know who it was, but forgot to wire up all of it only 40 turns. And I was at 150 turns, and I was trying to figure out how much money I would have wasted if that was up against Anthropic. And so basically what I'm saying is that the revolution can happen now, just like it did in '99 when we decided that open source was the way to go, and that we built this giant community of open source projects that have it paid for my house, it paid for my kids' college, So
yeah, and just I think all the reasons Brett said are the reason why open source models are so attractive for certain workloads, and we also see a lot of our customers at Neo4j adopting open source models. And one of the big drivers for that is, in a lot of industries, you simply can't expose your data to external LLM providers, which either for healthcare is one industry where this is a big issue. We have a lot of financial customers. They often have requirements on data sovereignty, where the data is stored. They sometimes, especially in security use cases or anything very sensitive, you have to have it all inside of your own data center. And that's simply not possible to do unless you're running the leading edge open source models. And this is a great way for you to not only meet some of those requirements, which normally you can't satisfy with the commercial providers, but also improve the reliability of your network. If you look at the uptime of most LLM providers, I was just looking at Anthropic's yesterday, there's more orange and red bars than there are green bars. They have so many outages on a continual basis, and it's rapidly expanding. Their customers are exploding. There's all these reasons why that their infrastructure can't get anything close to 5 nines. But if you're in a business where you actually need to have reliability and stability of your models and your systems, if you have your own resources and your own open models, you have a lot more control over that than if you're beholden to some of the large providers who, frankly, they have bigger customers paying more money than you do, and therefore you don't matter as much.
If you need uptime, you should buy Mindframe. So back to the original question. I think the two things. One, I think a challenge is pragmatic usage. everybody's getting the mandate from on high to just shove AI into everything where it doesn't necessarily make sense everywhere. Whereas like just deterministic, like regular freaking software is great, and like maybe just use that and then find the pain points where AI actually is helpful, which, you know, to his point, is like, oh yeah, that's what they did. But a lot of people aren't doing that. They're getting the mandate, they're shoving it in, and there's like decision trees where it's like, oh, actually a switch statement is what you needed, but now you have this thing that just like makes crap up and on to the, you know, different logic branches that go nowhere or do the wrong thing. And then number two, I think, is the evals. A lot of people aren't putting enough time and energy into doing evals of the inputs and the outputs and validating the quality of outputs they're getting over time as they change models, those types of things, doing like blind tests where you'll take the same input to the same with the same context window and run that against, you know, 4 different models and see, you know, grade it over time and see like in aggregate where are you spending money on a bigger model that you just don't need to, or where are you wasting more compute than you need to on certain types of tasks. So this is something that we've been doing a lot of internally, where we are finding that for like entire classifications of problems where the hypothesis was we need a frontier like heavy reasoning model. It's like, no, actually one of these like relatively small 8 billion parameter models performs, you know, within a few percent of what our desired, you know, quality outputs are, and it's just like, it's good enough. The delta in cost savings is just like, it's not worth the 3%
It's
difference.
probably not just cost; it's probably speed too.
Well, yeah,
Smaller models, on the same hardware, will move much quicker.
Yeah.
Yeah, and then you get into the expert part of it. So with the open source, I'll get to you a second. With the open source models, one of the things that I'm looking forward to is that, so the system I was telling you that I was building is going to have 4 or 5 different sections. We'll have a security review of the third-party component. There'll be export restrictions. There'll be a technical review. Like, I've got a technical review. How many of you have read every piece of line of code in the third-party software that you're using? Yeah, that's exactly what I thought. You know what the robots do? They read every line.
Mythos is reading it now.
Don't get me started on Mythos. So, but you know what the robots will do? The robots will read every line of code, and then you can generate evidence based on some deterministic stuff to begin with, and you can tell the model, hey, I think these 3 files are suspect. Make sure that I'm not hallucinating. How hilarious to ask a model to ask if I'm not hallucinating. And then, you know, go tell me the confidence on whether this evidence proves that this library does this or this and this. And the thing that I'm looking at is I'm going to have 5 specialists, right? And they may be built off of a Granite base model. They might be built off of DevStrawl. I don't know yet, because I haven't done my evals, because the worst part of AI is doing your evals. But I'm going to do them. Don't worry. I know I have to do them. Some sort of weird vibe check on what that model thought was the right answer. But yeah, so once you get to that point where you've got your evals and all that stuff, you can go through and test 5 different models and see what the different results are. You can't really do that with the frontier models. You're stuck with some giant expert that thinks it knows better than you. So anyway, that's just a couple of things. Yep, go ahead.
Yeah, I feel like this is a bit of a chicken and egg game, right? Because I've got that same mandate, right? Use AI. I've got opportunities that I see to use AI. We only have enterprise agreements with the big frontier models. It's super easy to wire into that and use it, but also like super expensive, right? But I need to prove that utility before we can invest in the hardware costs to be able to run the open source models, right? So, yeah, I was wondering, like, how do I bridge that gap, or how do I play that game and leverage open source sooner?
Unified memory on you're running a Mac. Unified memory on a Mac will run a really hot model. And I did all the original POC before I could. I didn't trick the associate software developer into putting the 3 GPUs under my thing. I just asked him, and he didn't think to ask his boss. So I have 3 GPUs now. But the point was that I did the proof of concept on my Mac using, it was painful, but I used a Llama. But I wouldn't do it now. I'd use VLM or VLM or Llama CPP. But the point is that a Mac with unified memory has enough space on it to do a big enough model. Like I was running Granite small h, which is 32 billion parameters on my laptop. It kicked me out of the meeting when I got it hot. and then I lost my audio and my video, but I was able to get through the POC, right? And so you've just got to beg, borrow, and steal to find where you can get it. But the whole point of what we've been talking about is that you don't need that huge model most of the time to do business type stuff. Now, maybe writing code, that's a different story. Mm-hmm. But like for like a simple decision tree or sentiment analysis, we've been doing that for years with tiny models.
So to the point, Gemma 4, 31 billion dents, is 3.2% lower in live Codebench v6 scoring than Opus 4.7. So now when you get into larger code bases for long-term maintenance, for like SWE-bench scores, it does drop considerably, but it very much depends on what you're doing. And so even for like the coding work, there are open models that are small enough to fit on your laptop or on like an AMD Strix Halo machine, which you know a lot of people have, like the Framework Desktop or like any of the GMK Tech, or I don't know, I think Lenovo and Dell have systems out now. But like there's relatively consumer hardware that can run these models locally. You don't have to spend $500,000 worth of hardware and rack and stack in a data center to get going. And yeah, it's largely task and fit for purpose.
The reality is most of the enterprise applications, they only need a very small model that basically understands basic dialoguing, right? Being able to talk to the user or to the application. And you don't need a model that knows, when the United States was formed. No, but it's true, right? Those frontier models, they know everything about everything, but it comes at a cost. When in fact, most of the application we have, like a typical application for an enterprise would be to have a chatbot that, will be supporting for like a product. What you need is a model that understands basic language so it can talk to the user and has been fed with the documentation of the product. That's it. You don't need this to know, when was the French Revolution. You don't care. This is just, blot that you're paying for that you don't need. So, the Granite models we have. This is IBM's business model around the models, is to really go for those small models, and that's a strategy. And in fact, in the latest version, we even have a model that's micro that actually can run in a browser. Okay, there's a GPU extension to the browser that you can leverage, and so yeah, I don't think, and especially to do like proof of concept kind of application, you can definitely use your laptop or some fairly beefy machine is enough. You don't have to invest in hardware.
Is there a concept of routing to a specific model based on exactly what the application is doing? Would you have like
Yes.
many potentially?
Yes. So if you look at like the LMD project or like some of the various things around the AI gateway routing in the Kubernetes ecosystem, like CNCF, they have this concept of like a sentiment analysis. So like when it comes in, very much, not to keep going back to this, but like if you look at how Anthropic does this, is like the way they do sentiment analysis is they pass it to Haiku. Haiku does sentiment analysis, and then it will route it to Sonnet or Opus if you don't pin to a model. Cursor does a very similar thing. It will auto route your request to a model based on whatever. And each of them has optimized for their own thing. And I think Cursor always optimized for cost, unless you tell it, no, like I need, I need max thinking or whatever. But the answer is yes. Like there are open source infrastructure components that you can deploy internally that will actually route this and kind of mimic the behavior you're seeing of these larger vendors doing that in a closed way.
The other one is that, so in the two projects I have right now, the grenade launcher and the one that's actually going to be in production, I've written the provider in a way that I can specify in the config file what models do what. And so, of course, I wrote my own agent harness, right? So I have complete control over where things are routed, and there's two places you can do it. You can do it on the inference side with routing, and then you can do it at the agent level in the harness. And so the cool thing about the harness was I was like, I'm not, if I wanted to use a frontier model to do the orchestration of the project, right? I can hook up to OpenAI and have a big model start the process. But when it calls the sub agents, because my harness is my harness, I can tell it to use local models to do the little stuff, right? And so, because there's no reason for me to pay money to have Opus compact or do a review of something, read this bash file. That's a waste of tokens. And so you can be very creative with how you route your requests inside. And as long as the tool calls, when you pass them to the model, as long as the model knows what the tool calls are and the harness knows what to do with it, you can do a lot of stuff. And
and that's a good point, actually. It makes me think of, another open source project called Goose, which is like kind of an agent runtime. It has this concept of recipes and sub-recipes, and each sub-recipe is effectively its own fully contained sub-agent. And it's another instantiation of Goose in a way that like your model provider, your model, your MCP, servers, your plugins, your context, your system prompt, the tool. Yeah. So like each one is a self-contained thing. So you can, to his point about like, as you call subagents, you can actually scaffold it to where like each subagent is very pinned to a specific model and model provider. So that's one of the things I've always found very fascinating about kind of the way that they designed it is it's not just creating, because like you look at like Anthropic or Codex, the way they do subagents is like, oh, you just slap it a markdown and it's still using all the same inference provider. But like some of these open source tools like Goose, they do it to where it's like, oh no, each one is self-contained. It can point to a different inference provider. It can point to a different model. It can come with its own set of tools to where this agent might have access to a different set of tools than that one. And then, you're managing your context window differently and various things like that.
you can also do the security at that level too. That's what you were getting to, right? So I could say that this subagent's only allowed to have read-only, and it's only allowed to have the read file tool, and the write file tool is reserved for this other agent with a bigger model that I trust to do the right thing type of stuff. Did you want to?
So we are at time, and I have decided that I'm going to talk to you all about, let's do a white paper, because there's a lot of good information that came from this, and I want to, does anybody have any final thoughts that they want to share?
Yeah, everything I said today will be wrong 3 months from now.
That's accurate.
Yeah.
So back to the very question that we started from on the open source model, I actually believe that a lot of the models that are available, they are really just binary blobs, right? And you don't have all what you need like you would do in open source software, as Adam was saying earlier, where you can actually rebuild the whole thing yourself. I think there's a race right now. A lot of vendors, they're trying to brag about how big or how good their model is. So in some cases, like IBM, as I just said, we have a specific target use case. So we are, motivated to build our own models. But I think soon enough, those models are going to become a commodity, and then there will be more interest in collaborating among the different vendors on actually creating models like foundational models that are, benefiting everybody. Because right now, everybody's spending tons of money, right, building their own models, and at some point, it's just not going to be worth it anymore.
Thank you to
My
our
prediction. We'll see.
Thank you all to our panelists. If you want to give a round of applause, please.